Today we're going to be talking about solving quadratic equations by graphing. So in section 4.1 we talked about what a quadratic equation is. When we graph it, it forms a parabola. Now, once we get an equation of it, it has to be equal to some value. Now in standard form, the quadratic equation is when it's equal to 0. Notice a cannot be 0, like here, because if it's 0, then the x squared term goes away. It's no longer quadratic. Now, when we graph them, or anytime you have a quadratic equation, its solutions or values that make it equal to its value it's looking for, which in our case in standard form would be 0, when it's equal to 0, those are called roots. And the roots are actually our solutions. Okay? And in quadratics we call those the zeros of our quadratic equation. So if I look at this one right here, you'll see that when I graph it, it crosses the x-axis, and so I get zeros for y at 2 points. Okay? So my solutions then would be x equals -2 and x equals 3. So this quadratic has two x-intercepts, and those two x-intercepts are its solutions, or its roots, at -2 and 3. Now, if I was going to solve this by graphing, it says to solve x squared minus 3x minus 4 equals 0 by graphing. So if we're going to solve it by graphing, we need to make a table of our values. First, let's find where our vertex is going to be. So that's at when we have -2b, or -b over 2a is how we find our axis of symmetry to find our vertex. Okay, so we would get -3, which would be a positive 3, over 2 times 1. Well, 3 over 2 times 1 is just going to be 1.5. So that's my x-coordinate of my vertex, okay, 1.5. Then I put 1.5 into my equation. 1.5 squared minus 3 times 1.5 minus 4. And when I get that, I get -6.25. So that right there is going to be my vertex. So I find that on my graph. 1.5 -6.25. Right out on the line, just a little bit off. There. So now that I know that my vertex is there, I can start making my table of values. Okay, so x and y. Now we said we wanted that negative or that positive 1.5 right in the middle. -6.25 is my vertex, and so I'm going to pick, we'll say 3 values above it and 3 values below it. So that would be 1, 0, -1. -1 right there, and then we'd also have 2, 3, 4 right there. Okay? So I go to my table, and when I go to my table, I put this into my y equals x squared minus 3x minus 4, second in graph, which goes to my table. And so at -1, my value is 0. At 0, I get -4, then -6 at 1. And then we see it starts repeating itself. And, parabolas do that. They're same as the left on the right by the axis of symmetry, which we found to be 1.5. So I graph those values. So -1, 0 is right there. 0, -4. Okay, 1, -6, and 2, 6, 3, -4, 4, 0. Okay, and we see our parabola is just like this. Now the important numbers that we see, again, are right here. We'll see that my y values are 0. So those are my solutions, where it crosses the x-axis right there, x-intercepts. So my solutions then would be when x equals -1 and when x equals 4. So this has two solutions at -1 and at 4. Here's a couple guided practice problems that you can try now. Feel free to try letter A first. Now, when we're solving quadratic equations, you can have 3 different possibilities. The first possibility is where your vertex sits on the x-axis. That's when you have one real solution. You can have it so that your x crosses the x-axis at 2 points. 2 real solutions, like our last example. Or you can have it such that the parabola never crosses the x-axis and thus has no real solutions. Now, example 2 says to solve 14 minus x squared equals negative 6x plus 23 by graphing. So if I want to graph it, I have to first get it into standard form where it's equal to 0. So I'm going to add 6x to both sides. And so I get, and I'm going to switch the order just a little bit because I like the x squared in front, negative x squared plus 6x plus 14, remember that minus x squared has to stay with it, equals 23. And so I subtract 23 from both sides, and I see that negative x squared plus 6x minus 9 equals 0. I now have it in standard form. And so if I want to find what my solution is, I'm going to make my table of values. And then I can graph it. Okay? Well, I don't know where to start, so what I'm going to do is I'm going to find my axis of symmetry to find where my vertex is. So negative b over 2a. So in our case, if we look right here, our b is 6. So it would be negative 6 over 2 times, and then a is negative 1. Okay, so negative 6 divided by 2 times negative 1 is negative 2. So I get 3 goes right in the middle. Okay, so my 3 goes in here. And then I'm going to put 2 above it. So 2, 1. And then I put 2 below it. 4, 5. Now I go into my equation, or into my y equals on my calculator, and I put negative x squared plus 6x minus 9, and I hit second and graph, which gives me my table. And so when I get 1, that's going to be negative 4. 2 is negative 1. 3, our vertex is actually 0. And then 4 is negative 1. And then 5 is negative 4. So you'll see it starts repeating itself. So our vertex, when I graph it, okay, when I go to my calculator and graph this, it actually sits right here, and then 2, negative 1 right here, and 1, negative 4 is here. And so my parabola actually sits on the x-axis. So it only has one solution. So my solution then would be x equals 3. Is my only one solution. Here's a guided practice problem you can try. Try letter B. It says, use a quadratic equation to find two real numbers with a sum of 15 and a product of 63. So, this is what I'm going to do. I'm going to say x plus y, is our sum, is equal to 15. And x times y equals 63. Now, to set this up as a quadratic, I'm going to have x squared. Okay? So what I'm going to do is I'm going to solve for y right here and then substitute it into here. So I subtract x from both sides. And so x, or y is equal to 15 minus x. So I'm going to take this 15 minus x and plug it in for y. So I get x times 15 minus x equals 63. Okay? I use the distributive property, and I give the x to everything. So it's going to be 15x minus x squared is equal to 63. Now this again is not in standard form yet. So I'm going to subtract 63 and do a little rewrite on my problem. So I move negative x squared to the front. Then I have plus 15x minus 63 equals 0. Okay? And so I have to figure out where the vertex of my parabola is. So negative b over 2a. Okay? So my b is 15. So negative 15 over 2 times negative 1. Okay? Well, negative 15 divided by negative 2 is going to be a positive 7.5. So that's going to be in the middle of my table. So I go and make my table. Okay? X y. And so I'm going to have 7.5 right in the middle. Okay, I put that all into my graph, and then I'd have 7, 6, and then I'll also do 8, 9. Okay, so I go to my table, and I see that at 6 I get a value of -9. At 7 I get a value of -7. Then at 8 I get a -7. And at 9 I get -9. So I figure out what it is when I put 7.5 in. Okay, and so I get 7.5 squared, -7.5 squared. Alright, so that's plus 15 times 7.5 minus 63. And I find that to be -6.75. Okay? And so we can see that this, even if we hit the graph button as well, that it never crosses the x-axis. So since it never crosses the x-axis, there is no solution to this problem. Okay? Here is a guided practice problem on the bottom. Try that one now. Alright, so now something that's rather interesting is that if you're looking for a table and you'll see that it goes from a positive y to a negative y, that a 0 is going to occur between this. And so that actually makes it easier trying to figure out where some zeros might occur. Okay, so it says, solve x squared minus 6x plus 4 equals 0 by graphing. If exact roots cannot be found, state the consecutive integers, so what they're between, to find the roots. So essentially, all they're asking us to do is make a table of these values right here, right? So let's make a table of our values, okay, x and y. Now we don't know where to start. We always figure out where our vertex is going to be by putting in negative b over 2a. Okay, so negative 6 is just 6 over 2 times 1. So that's going to be 3. So I want 3 in the middle. And I'll do, let's say, I don't know, 3 below. So 4, 5, 6. And I'll do 3 above. 2, 1, 0. And now I go to my equation. So x squared minus 6x plus 4. Second in graph goes to my table. And so I get 4, -1, -4, -5, -4, -1, and 4. And so the important values they're having us look for is, do you see how it goes from a positive 4 to a -1? It means that an x occurs here. Okay, an answer. Also, there'd be a solution right here. Alright? So that means that on the x's, there is a solution between 0 and 1. So solution right there. And also there's going to be one right there. Okay, so where do my roots occur? Well, 0 is less than x, which is less than 1. And 5 is less than x, which is less than 6. So my two solutions, one of them is between 0 and 1, and the other one is between 5 and 6. Here is a guided practice problem that you can try as well.